Here's a familiar troubleshooting story. An e-commerce shopping app that fails during checkout in different ways in Android and iOS. The front-end support team is complaining that on the Android app, the place order button fails, but silently. An iOS engineer reported an error in their user interface. In that case, the app was properly reporting a 500 internal server error. Something is definitely wrong. Meanwhile, the Android engineers opened up the Logcat viewer in Android, which showed the same error. All right, so now we see the error happens on both iOS and Android, but in either case, the APIs are reporting the equivalent of stuff broke. In some organizations, now would be the time to throw this over the wall to the back-end team to deal with it. And so we'd have two understandings of the truth, one hazy about the back-end and another confused about the front-end. But with end-to-end observability, we can see everything from the mobile, native, or web front-end request all the way to the services involved in the checkout process. Let's go to Honeycomb and take a look at the Android dataset's launchpad. It's reporting errors. I'll click on the errors number, which runs a query, and we see a few different ones. I'll locate the internal server error message, filter only to that value. And now I see only the internal server errors. And because our applications are instrumented with OpenTelemetry, we can get to the root cause. I'll click the Traces tab. And I'll click on a trace ID to view that trace. This trace shows the front-end Android interactions all the way back to the back-end services. Trace spans that have a status of error are marked in red. Log events are annotated with a circle. Oh, it's an exception. This exception event contains the original Android trace we saw in Logcat. To get to the root cause, which is often the last error in an end-to-end trace, I'll click on the Spans with Errors box, then click on the up arrow to go back around to the very last one. Here we see that the payment service is what's actually causing the failure. And it's complaining about a loyalty level of gold, some sort of invalid token. That's a lot different than the 500 internal server error. But we have other errors above this one, so let's take a look, moving up the distributed trace to see how the error propagates upward. Not all errors contain exception events. Some are marked as just error events. This depends on how the error was actually reported. In the checkout service place order event, we see that we no longer have a stack trace, just the message. While executing API route API/checkout in the API gateway service, we still have the failed to charge card message. It's when we walk up the stack that we find out that earlier nodes in the process have erased that piece of information and just report a 500 internal server error. And that's the power of front-end observability, going from simple errors on the front end, and instead of looking at them in Logcat, where you're digging through tons and tons of logs, really gaining a shared understanding of the entire stack trace, end to end.